Hello everyone, let's look at Dijkstras algorithm today. So here in this JSBin editor, I have a simple function which we are going to add Dijkstras algorithm into it. So we have a simple graph here and we are expecting a result from this Dijkstras algorithm to get the shortest path between the two nodes A and E, and they are connected as given in this graph. They have weighted edges, and these weights are positive in nature. And here we see the shortest path, which is ABC. This is the traversal to get to E, and from A to E, and the total distance being the shortest total distance being 6. So let's understand Dijkstra's algorithm, and let's see how we can implement the Dijkstra's algorithm function. Before starting this, let us look at motivational quote. Work hard every day, not because success is guaranteed, but because efforts builds discipline, and discipline opens doors to opportunities you can't even imagine yet. Every page you read, every problem you solve, every hour you dedicate adds up. Stay consistent. Your future self will thank you for not giving up today. So there are few things to understand. So working hard and being consistent is one thing, and this will eventually build discipline, and discipline will uh, lead to results that we cannot even imagine. So this statement here says even small actions which in which we stay consistent will add up to a bigger extent. So adding up small things every day will make us better, and this will eventually pile up. And once after certain duration of time, when we see, we will be lot more mentally strong, mentally lot more knowledgeable, and we would thank ourselves with the progress that we have. Okay, so let's understand Dijkstra's algorithm with the graph that we have here. So let's draw this graph. So we have A, which is connected to B and C. From A to B, it is 2, and C from A to C it is 4. Similarly, we have B, which has connected nodes A, and B is also connected to C with value 1, and a new node which is D, and B to D is 7. Similarly, we have C, which is connected to A and at a weighted distance of 4, and C to B is of distance 1, and there is a new node E where distance between C and E is of distance 3. And now looking at the D is connected to B and has a distance 7, and D to E is of distance 1, and D is also connected to a new node. D is connected to B and E is connected to C and D. Okay, so these are the set of nodes that are being given. So 1, 2, 3, 4, 5. These are the 5 nodes. So we are looking to calculate the shortest distance between A to E. To do this with Dijkstra's algorithm, we firstly keep track of visited nodes and unvisited nodes. store certain data such as a node and a distance in a priority queue, and we constantly check and update the shortest distance if it is shorter than the current distance that is needed. And add to the priority queue for further exploration. For this is priority queue. Repeat all nodes are visible. So these are the steps which Dijkstras algorithm performs to find the shortest distance. And few conditions here are weights of should be positive. Let's see how we can. Let's have a dry run on this particular graph that we have here, and let's see how we can use the Dijkstras algorithm to calculate the shortest path. Okay, let us do a dry run on simple the steps that Dijkstras algorithm is mentioned with, and let's see if we can find the shortest distance between A to E. So we have unvisited nodes and visited nodes. Visited nodes initially will be empty, and unvisited nodes will be all of these where A, B, C, D, and E. And we would use a priority queue to keep track of the distance for a specific node, and we would be doing this with a priority queue and in heap data structure and previous node. Okay, so let's firstly take the starting node, which is A, and let's mark the distances of let's mark the starting distance with 0 and all the other nodes with infinity. let us consider this as step 1. In step 2, let us consider this as step 1 and this as step 2. And in step 2, we step 3 we explore the neighbors of this A node, and we see that A has a neighbors of B and C as per the graph, and we add A as visited, and we also append priority queue with the nodes B and C with the distances infinity and C as infinity to be further explored. So let us look at B and C nodes which are newly queued to the priority queue to explore more of the shortest distance. So from B, we see that connected distance between A to B is 2, and the previous node, let us mark it as A, and A to C is of 4, and A. So once we have done that, we also check the neighbors, which are B has a neighbor D and C, D and C. So B to D is 7, and B to C is 1. So here we already see B to C as 4, but we replace this entry with 2 plus 1. That is, A to B is 2 and B to C is 1, which takes up a new value of 3. And here we also change the parent node of this one to B. So next we will be marking B and C as visited, and we will be removing them from unvisited nodes, and we will be marking B and C as visited. And now we will also be queuing the node, and C is connected to E. Exploring C, we also see that C is connected to D, which is C to D 4 to 1. So this already has a value 3, and we would not be changing it. So we leave C to B as unchanging value, while we explore this new unvisited node, which is E, and we mark this as the distance 3 from the previous value infinity. So now we would also be having these set of values dq, and we would be having to explore more on the elements D, which has a value 7, and E, which has a value 3. So we see that D has a neighboring node D, and D to B is 7, while D has a value. Okay, so we see that D has a neighbor C, E also, but So we need to write it as 3 plus 3 because C has a value 3 as we saw here. So this will take up 6. So as we see, D has a value 7 and D has a neighbor B and E. So uh, and we would be appending D and E to the unvisited nodes, or we would so A, B, C are the nodes that are visited, and now we need to explore more on the D and E newly added private key elements. So we have our table. Let me rewrite my table here. A has a value 0, and B has a value 2, and C has a value 3, and this is from B, and D has a value 7, which is B, and E has a value 6, which is from C. So now we want to explore D and E, and D and E are the two unvisited elements, while A, B, C are all explored. So the neighboring elements to D is E. So from D we have a value which is 7. This will take up plus 2 as we have B value 2, and this would be 9. Okay, so this would mean A to D is 9. And E has a value 6, which means 2 plus 1 plus 3. So this is the final value, and all of the as we have seen here. So these are the final set of values that we have. So now in order to let's understand what is the, since all of the other elements or the connected elements to D and E are already visited, we can simply calculate A to E, which is A has a neighbor, A has a prior element C, and C has a prior element B, and A, B, E. A to B is 2, and C has a value 3 and 6. A to B, this is 2, and B to C is 3, and C to E is 6. So this is 2 plus 3 plus 6, this is 11. So we are having to say A, B, A, B, C, and D. So 2 plus 1, 3, 3 plus 1, 6. 6. So 6 is the value that we see here. And then in order to travel to E, so we have to check the previous node, which is C, and C has a previous connected element B, and B has a connected element C. So this is the way to check this. Let us look at another example. we are asked to traverse from the point A to E, we need to find what is the distance, and this is the starting point, and let's say this is the starting point and this is the ending point. Let's see how we can use Dijkstras algorithm to find the shortest path in such a weighted directed undirected graph. So we know that we will be having visited and unvisited graphs, unvisited array to store the nodes, and visited so let us have a priority queue where we have a node distance, our previous node, and we since this is the starting node, we mark this distance as 0 and all the others as infinity. Let us explore the connected nodes to the starting node, which is B and C. So let us mark them, and let us mark A as visited and B and C as unvisited. From B and C, we know that the distance from A is 7 and 3. So this will be 7, it will be 7 and 3. So now let us mark B and C as completed and add unvisited nodes which are neighbor to B and C. So C has a connected node which is D, and D has a connected node D and E. We would not be considering A and C as they are already visited. So now we only have D and E. So let us explore the node D and what is the shortest path here. So since both of these values are 2, we mark this value as 2 either from B or C. So we will take C since this was having the shortest path of 3 from the start node, and we look at E, which has a shortest path, and we mark C as completed, D as completed, and we explore E, which has a shortest path from B as 6, or we can say B to E is 6. Now let us see what is the path that we are required to take here. So we see D and C. Okay, C to D. D has a values and 2 plus 3, since C has a value from A as 3, so we mark this as 5, and we see that E has a connected node of B and T. Considering the shortest value B to E, we either need to consider D, the path traversal from D, which is D to E. D to E is D has a value 5 plus 4 to E, which is 9. We we can either take 9 or we can consider B as a connected node and P has a value 7. 7 plus E from P will take 7 plus 6. So we check if these two values which is greater. So we obviously say that D is the shortest path and we change this value to 9. So to move from A to D, we will have to travel A to E, we will have to travel to D, and D has a node C and C has a node A. So A to A to C, A to C is 3 and D A to D is 5 and this is going through the node C and A to E is of a length 9 which is having to travel through the node D. Let us try implementing Dijkstras function in JS bin JavaScript editor. So here in this JS bin JavaScript editor, I have a simple priority queue class which has a queue property and this is an array. We have simple methods such as enqueue, which wherein we push the value based on this, sorted based on the weighted distance, and we also dequeue, simply removing the particular element at which is at the first end of the queue and start of the queue. And we also have a method isEmpty to check if the queue is completely empty. So let us start implementing this Dijkstras function. So firstly we keep track of distances in a simple map. And we initialize a priority queue. And we enqueue or we mark all the initial distances at infinity and all the nodes uh, in the previous node as none, and we enqueue the specific element which is at the start. So let us do that. So priority queue is not empty, and we perform certain operations such as exploring the neighboring node, and also updating the distances object and the previous node, and after each before each or after each operation we also dequeue the specific node that we have explored. So let us firstly take the value, and let's call this current node or just current queue. So here we are checking if we have reached the end node, and we unshift the we unshift the current node which we have stored in temporary variable. We explore the neighboring node of the current node with the input graph argument that we have, and we check if the neighboring node to the current node has a shorter path than compared to the one that we have in the distances object. If this is true, then we update the distance of the neighbor. And we also update the previous node's object with the current node. for its connected nodes, and also we explore further distances on it. And if there is no successful end path that is found, then we return there is no path that could be found for specific specified start and end node, and we return a distance of infinity. So let us understand what we have done here so far. So we have initialized a couple of hash maps to store distances and previous nodes. And we have a priority queue here, and we are having to assign all the values or distances to each node as infinity if it is a start node based on the argument or function argument that we get. So we assign the distance as 0, and we also specify all of the previous nodes as null, meaning that we do not have any connected node to it, or we do not have a reference to any previous node, and we enqueue all of the nodes along with the distance that we have from the original graphic code. So once we do that, we start with the iteration where we explore each of the nodes that are enqueued in this queue, and we at each stage we dequeue a specific element, and we check if we have reached the end of the condition, and we return this value where we return the path which is the start, which is start to the end, and we are doing it here where if the current node is matching the end node that we are looking for, then we take the current node and assign it to a temporary variable, and we start adding each of the previous nodes to the path. And this is seen here. And this gives us all the connected paths from the start to the end node with this piece of while loop here. And the distance is simply the distance of the end node, which we would be storing it in the distances hash map. So in this piece of for loop, we are checking each of the connected graph to the current node that we have dequeued, and we explore if it has a distance less than uh, the one that we have already stored here. So all of the values initially will be updated to the nearest distances, and here we are just having to update the distance in the distances hash map, and also the previous hash map with the reference to the previous node, and we also enqueue the current neighboring node for further exploration for shortest path. So let us see if we can run this Dijkstras function and get the expected output here. Okay, As you see, with this graph, so we are having to travel from A to E, which has a total distance 6, and the path that we need to choose is A to B to C to E. And this is the same thing that we saw in our open board, where we were having to explore the shortest path from A to E, which is A to B to C to E, and we saw it here. Alright, so if you like my video, please consider showing a like and subscribe to my channel, and you can find the reference code in the description thing. Thank you.